So if I just square both sides the way it is, what happens over here? You get 64 y equals y squared. Never, ever, 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 ever divide by a variable or a variable expression, because then you're losing an answer. Now, the shortcut is you could say, well, y could be 0. And then once you say y could be 0, you say, well, okay, what else could it be besides 0? Then I can divide by y. Why can I divide by y then? I just said, assuming it's not 0, what else could it be? The only way I can divide by y is if I say it's not 0. If you do divide by y, you're saying it's not 0, you're losing that answer. So you really should bring it all to one side. And then factor. Yeah, exactly. I have a y that's got a square on it. It can't go together with the other y. Let me get them all on one side. Get it equal to 0. And then you'll get both answers. Cool. Is that a question about this? Are you guys cool with that? What are the answers here then?
Y equals 0.
Y equals 0. Or y equals 64. Yeah.
Number 70 from the same section.
So 70. The one about the blast furnace?
Yeah.
Yeah. Okay. Sounds like this is a... So they give us this equation. So this is an equation that says sound is transmitted across the surface of a metal. Try to measure how hot something is. So you can imagine, this is kind of a funny question. I love it. And it's similar to how do you measure how cold an atom is or something. Well, how do you measure how hot something is when every damn thing... Let me see how hot it is. Oh, it melted. Shit. So how do you tell how hot something is that would melt every device we have to measure how hot it is? This is kind of cool. They see how the speed of sound changes as it goes across the surface of this metal. So it's going to change a little bit based on how hot this stuff is. So they have blah, 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 blah. The speed of sound in feet per second at a temperature of T degrees Celsius. So if it's this hot, this will be the speed of sound. Neat. Blah, 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 blah. So it says find the temperature where sound travels 1,502.3 feet per second. So they want the sound to be 1,502.3 feet per second. They want the speed of sound to be that across the surface of this metal. And then say what temperature would achieve that. So on one level it's just plug and chug. On another level it's plugging in the worst place you could plug, and because you have to solve for T, which is disgusting. But is everybody with me so far? Is it really, really, really important that you understand any of the physics behind this? Hell no. You don't even have to know exactly that it's speed of sound and molten whatever the hell. All it cares about is you plug the right thing in for T and you plug the right thing in for S. Right? That's really what's important. So the speed of sound, that's the S. That's what they give me. And they ask me, what's the T have to be? So just got to solve for T now. So if I plug that in, I get this. Familiar equation. We see this all the time. That's a complete joke. We don't see this all the time. So what do you think the first thing would be good to do here? Yeah, I wouldn't square both sides here. No. I got ugly ass big number, ugly ass big number. I would divide by this thing. It's already decimals. Who cares, right? So here's one place I would definitely just divide. Here I don't want to divide because then I bring in fractions and that could possibly mess me up. Here I'm not going to bring in fractions. Screw it. I'm going to just freaking divide and get a decimal. Who cares, right? I mean, that's fine. So I would divide this sucker out of here. And then square both sides. Is that cool? Because everything else that I might want to move is stuck in the square root. I can't move it until I get the square root out of there. And the way to do that is to square. Make the square root die. So then I get whatever the hell this number is, squared, equals 9t plus 2617 over 2457. Then you multiply that, subtract that, divide by 9. I mean, now after that it should be easy. You just got an ugly number here. But you have got to get to the point where I don't care how ugly the numbers are. Right now, that's a pretty simple equation to solve. I don't care what the hell this number is. I multiply whatever the hell it is by that, subtract the 2617, divide by 9, see what the temperature is. Cool, cool, cool. Is that all right? Yeah.
Oh no, I want to ask you about another question.
Sure.
Number 5. 2.6.
Number 5. In 12.6?
Yes.
Oh.
I did it, but I got a big number. So I don't
No,
know
no, no, that's not what they're asking you to do. They're not asking you to solve it.
Okay.
They're saying classify these as true or false, right?
Yeah.
Yes. The statement says this is equivalent to that. Is that true or false? Is this equivalent to that? And I know on one level you're like, this is a trick question. No, it's as easy as it looks. Are these equivalent? Yes, because if I add 8 to both sides, I get this. And adding 8 to both sides of an equation maintains that equality. Therefore, those statements are equivalent. That's why I'm able. That's the logic. That's the law. So every damn thing you write down better be equivalent to what you had before it, or else you did something wrong. You did something illegal. Yeah. So these are equivalent. I like it.
Because I was following the example and I did get the 15, but then on the example it squares it and I don't know.
Yeah. You get 15 squared, which is semi-big. Yeah.
So
But you don't. The question doesn't want you to solve it. It just wants to say, are these equivalent, true or false? Yeah.
what about number 10? How does number 10 solve?
Let's see. 10. You know, and I had a student a while back that proposed to me. I don't know if he ever did this. I told him he should write into the Mathematical Association of America and say, I propose that we change the square root symbol to be this. So I can tell where the hell that thing stops. Because the biggest mistake I see is people write this and on the next step they've got that. That's not the same thing. That's definitely not the same thing, right? So it's really evil. So if it just had a back wall, that'd be awesome. So it's not a bad idea. You can just kind of personally inherit that. I got to start making myself do that too. That would be kind of neat. So now you can tell this is by itself. So what's the first step to solve this thing?
The one.
Yeah, get the radical by itself. Right. You are the tyrant in charge of this country. Get the radical element by itself. And square both sides. I love it. If you're a student that checks in and out of my class every now and again, and you hear me say that, you're like, what the hell is he talking about? What class is this? All right, so square both sides. Yes, and I know there are people that check in and out. 2x equals 9. Nice. 2x equals 9.5. And of course, you desperately have to do what? Check this. So when you plug it in twice, 9.5 is 9. Square root of 9 is 3, minus 1 is 2. Check. So it works. You must check every radical equation, because it could be an answer that doesn't work.
12.8. 73.
70, 78,
3.
73. Oh, yeah, this is good. Well, real quick, if I had a little recall, if I had this, how would I do that problem?
Multiply by 4, 5 plus 1.
And what's the name of that? Multiply by the conjugate. I like it. The complex conjugate in this case. The conjugate. I love it. Which now sounds like we're in English class, but oh, 4i plus 1 or French. Conjugate your verbs. So multiply by the conjugate, which is just changing the middle sign. What that does is it forces the bottom to lose its complexity, right? To become real.
Is that a 1?
Purely real. Say again?
Is that a 1 on top?
Yes. Now I do that example because the question really is, and then blah blah blah, you multiply this crap out. The question really is this: 5 minus 3i over 4i. So, to be honest, it's the same thing, really. You can look at it as two ways. You can either just multiply, and the funny thing is, if I had to rationalize this, I know I keep throwing different problems up here, but if I had to rationalize this, what would you multiply by?
2 square root 3. Square root.
Multiply by what? Square root of 3. 2 is fine to me, right? 2 has no problem. The radical 3 is what I'm going to get rid of. So really what I would multiply here, the 4 is fine. This is a kind of a special case. You could either treat it like this and multiply by negative 4i and be all by the book, right? Which you should tell by now I don't necessarily like being by the book all the time because it's extra crap you don't need. Just multiply by I over I. Or even better, what is 1 over I? How would I do that? Just multiply by I over I. I get I on the top, what do I get on the bottom? I squared, which is negative 1. So 1 divided by I is negative I. That makes sense, because I times I is negative 1, so negative I times I is positive 1. Maybe. I'll let you guys absorb that. Some of you guys have a cool look in your eye like that. I see what you're doing there. So here, this is almost kind of silly now. 1 divided by I is negative I. So really, this becomes negative I times that. This piece becomes this. Neato. You have no idea what the hell I just did. You have no idea what's got to do with the problem. You can just take the problem and shove it. No, you can just take the problem and multiply by I over I. You can multiply by negative 4i over negative 4i. You're going to have some 4's cancel eventually anyway. Right? You can do it any of those ways you want to. But dividing by I is the same thing as multiplying by negative I. Very freaky. Yeah, so if I do it this way, I just get negative 5i plus 3i squared, which is minus 3. Is that cool? Over 4. Done.
Isn't that 4 a negative 4 because it's the i's right there?
If I do it this way, the way you're saying,
Yeah.
then I'll get 5i minus 3i squared. Is that cool?
Yeah.
Over 4i squared. So I'll get where am I at? 5i plus 3, is that cool? Over negative 4, and the only difference there is I brought the negative up. Those are the same exact thing. Cool.
Because I think the book does it like that.
Yes, the book will do it like that. That's by the book. This is being more smart about it. If I just have something divided by 4i or 7i, it really just brings that up and makes it negative, because I know 1 divided by I is negative I. Do you have to know that? Do you have to understand? No, you can always just do it like this. You can just do the conjugate kind of idea. No problem with that either. Yeah.
Did you do number 90 equals 20?
Yeah. Everybody decent with that?
Excuse me.
Yes.
What I by 3I, I should change the sign to positive.
I love it. So negative times negative is positive.
Okay.
I times I makes it negative again. Cool. You don't have to skip the steps I do, right? When you're doing it yourself. But that's quick. Those go away, and then it gets brought back because the I squared brings the negative back. Okay, cool. So, I mean, I've got to be a little careful with you guys. So right here, I certainly could have done negative 5i plus 3i squared, right?
Yes.
Over 4, and that's what leads me here. Cool. So what's
70 or 90?
90 in 12/8? Okay. Oh yeah, all right. I think, were we talking about this? Yeah. I think somebody came up and asked me this or something. What's the idea behind this? How can I even start to try to do this problem? What do I have to understand going in?
I add 5. I 5.
I-70.
The pattern. I like it. That's a good word. I like the word pattern. So I to the first is I squared is negative 1, I cubed is negative I to the fourth is frequently 1. And then it starts over again. I to the fifth would be equal to that, I to the sixth would be equal to that. So every fourth one, it goes back to 1. So if I divide this number by 4, first off, what's negative to the 71st power?
Negative.
Negative. Cool. Now I can just focus all my attention on that. Makes it a little bit easier maybe. If I divide 71 by 4 and see what the remainder is, this is a really cool idea. This happens a lot more than you might think in mathematics. If I see what the remainder is, I see where I am in the cycle. Every fourth one. So if it went in evenly, 4 goes into 68. So I-68 would be this. Then I-69, I-70, I-71. Right? Because 4 goes into 71 how many times? I don't really care. With remainder, 3. Because 4 goes into 68. Right? That's what's important. And remainder, 3. So it's going to be here in the cycle. I desperately want you to see it. Because I can keep going. Are you guys cool with what I did here? I to the fifth would be this. If I to the fourth is 1, then I to the fifth is that times I. It starts over again at I. So then I to the ninth would be this. And I can just keep going with this until I get to 71. Or I can step back and say, screw that. Let me just divide by 4 and then see where the hell I am. Without having to make this freaking long-ass list. Right? That's all you've got to do. So I just took the negative out of the way so that didn't freak me out. An odd number of negatives is still negative. Cool. And then I to the 71st would be remainder 3. Negative I. So negative I is I. Cool.
So we don't care about the number, just the I.
Which number?
The 71.
We desperately care about that.
I mean, yeah, but to show it, we just counted the remainder.
Yeah, so really kind of behind the scenes here is this.
That's I mean.
Do you see that?
Yeah.
That is 1, because that's the fourth step in the cycle. So it's going to be 1. And then that is negative I. Cool. So all the 71 really is important is that it's 3 off from something that 4 goes into. That's what's important about 71. So it could have been any number they wanted to as long as it's 3 off from a number that's a multiple of 4. The answer would be this. Yep. So if they would have made this 711, same exact, not there, but the same answer. Because 711 is 3 off from 708, which 4 goes into. 4 goes into any number where the last 2 digits are divisible by 4. I don't know if you guys knew that. It's really neat. Some of you guys know that. Okay. Yeah.
What about 85 in that same page?
Same thing. So, how many times does 4 go into 32?
8,
With remainder 0. Right? So that means it's 1. It goes in evenly. So it must be here. Right? Or even if you like, what's I to the 0? Anything to the 0 is 1. So as remainder 0, it's 1. If or goes in evenly, it's 1. Either way you want to look at it. If there's no remainder, then it's nowhere in the cycle. It must be 1. It must be at the beginning. Does that make sense? So any number I put here that's a multiple of 4, it's 1. It's really freaky, by the way. I mean, the fact that I acts like this. But I is basically a number like 1. And what's 1 squared? 1. What's 1 to the 5th? 1. I mean, so it should have something similar to that. Maybe a little bit uglier. And there you go. It takes 4 to kind of cycle through, whereas 1 is always frickin' 1. So it takes 4 to cycle through the I, but we shouldn't be overly surprised that it has some kind of pattern to it. Yeah?
What time you divide by 4? What time you divide by 3? What time you divide by 2?
Say again?
What time you divide by 4? What time you divide by 3?
What are we
Yeah.
dividing? Oh, 71. 71 divided by 4 is something, remainder 3. That's what's important.
Yeah.
So it tells me I'm in the third one in. If you divide the power by 4, see what the
So
remainder is.
every time you just divide by 4?
Yeah.
So if we divide by 4, I'm still just 2, so you minus 1.
Yep.
Okay, thank you.
There you go. That's the beauty of the cycle.
Finally.
I was trying to problem how you were getting.
See, it's amazing. It's always a question of how to say something. And I'm like, that's exactly what I just said, but I didn't say it just like that. Okay.
I was trying to find how you were getting those numbers. So if you just divide whatever number they give you by 4.
Yes.
Okay.
Okay. All right.
So on 95, will you divide the 2 over 4 and the 4 over 4?
Well, you have to do this separately. Yeah, I squared plus I to the 4th. This one's nowhere near as bad as it seems. I squared is negative 1. I to the 4th is 1. Yeah.
You're just saying it for your pi, you're just saving it different. So if it goes in 4 times evenly, it's 1. If it's not, then it's negative.
No. If it goes in evenly, it's 1.
Yeah.
If it has a remainder of 1, it's I. A remainder of 2, it's negative 1. A remainder of 3, it's negative I. Goes through that cycle. All right, so if I ask a question like this in the test, which I will, you have to know these to know what the answer is going to be depending on what part of the cycle you're in. Yeah. Okay, so let's get into some new stuff. There is a quick little section that has, it's not exactly mimicked in the blue book, so I'm not sure how much I want to get into it, but both books have something about special triangles. And, the first thing I want to say is, you have a right triangle, what's true about these sides? Yeah, cool. A squared plus b squared, c squared. Pythagorean theorem. Pythagoras had all these people that followed him, and they did most of the work for him, and he got all the glory. You didn't know that. That's the way it always works. But if I have an equilateral triangle, this is equilateral. What does that mean, equilateral? Yeah, all the sides are the same length. So how big are the angles?
36, 90.
Careful.
That was 60.
If all the sides are the same length, all the angles have to open up the same amount. If there's 180 total, each one gets 60. I love it. You guys semi still with me? Could I use this idea here?
No.
Why not? It's not 90, right? How big are the sides?
16. Oh. 3.
I love the question. Do you know how big the sides are?
No.
I don't know how big the sides are either. So how big are the sides? X,
180
X, X. I love it. Okay, cool. So, isn't that mean? I love you. That's why I'm a math teacher. But that's what you do. If you don't know what something is, then you call it X in algebra. So it's X. How can I create a right triangle to help me figure out relationships between the sides here? How could I create a right triangle?
3x equal 180.
These aren't angles, so they don't have to be 180. Right? I like it. So if I cut this straight down, I made a right triangle, right? As long as you do it straight down. You with me? How big is this angle here? 30. It's going to cut that exactly in half because of all the symmetry. How big is this side here?
1/2
I love it. X over 2 or 1/2 x. So I have a right triangle there. You guys, how we doing?
Wait,
You're
why
loving
did
this,
you get
huh?
X over 2 again? Oh.
Because I cut that side in half, yeah. Right? So I don't know if you ever heard of 30, 60, 90 triangles. If you've taken geometry sometime in your life, you should have heard of 30, 60, 90. I don't know if you've ever been shown this as to why they work the way they do. But I've got a right triangle here, right? I've got one side I really don't know. I'll just call it H. I just want one variable. I don't want to have H in there too. So I want to figure out what H is in terms of these other two things. Can I do that now? Hell yeah. What's the most important side in here as far as that formula is concerned? What's the most important side to know to use this formula?
Half edge.
Which side really matters that you figure out what it is? The hypotenuse. I love it. So what's the hypotenuse here? Yeah, the one across from the 90-degree angle. So if I set this up, I got x squared equals x over 2 squared plus h squared. You with me? The two legs squared added up equal the hypotenuse squared.
What is that under the X? Oh, X2, okay.
Yeah, it's trying to be a 2. So if I solve this for h, what will I get? I get h squared equals x squared minus 1/4 x squared. You guys cool with that? That's 1/4 x squared. Subtract it. How do I solve for h? Or actually, what is a full x squared minus a quarter x squared? 3/4 x squared. I love it. And then what can I do to solve this? Take a square root. Now normally when I take a square root I have to put a plus or minus, but we're talking about side lengths here and heights. They're not going to be negative, so I can just take the pure positive answer. So I get h equals what?
3 over 4. X.
Square root. Square root of 3 is what? I don't know. Square root of 4 is 2. Square root of x squared is x. As long as it's positive, and I know that x is positive, right?
How did you get the 3/4 again from x squared minus 4?
Yeah, one full thing. What's one full thing minus 1/4 of that thing?
Oh.
If I had a full tank and I just burned off a quarter of a tank, one thing minus a quarter of those things is 3/4 of those things. Always. Right, good like terms. So this might possibly sound familiar to some of you guys. If you remember your geometry, that root 3 over 2? Right? So if x was 1, and I had a 30, 60, 90 triangle, what's this side? If x is 1, this side is 1/2. And then this side, the h, the height, is root 3 over 2. Maybe. So this is a little bit of geometry.
Can you do a squared plus b squared and c squared for that too, or no?
It has to follow it. Because where did we get... I got this and this from the setup. I solved h from the Pythagorean theorem. So for any value of x, this has got to follow the Pythagorean theorem. Because where did it come from? Pythagorean theorem. Yep. This is kind of neat. Any 30, 60, 90 triangle, any of them, any 30, 60, 90 triangle you have, whatever this side is, this side has to be half of it, and this side has to be root 3 over 2 times it. So root 3 over 2 times 4 would be root 3 times 2. Kind of freaky. That's the 30, 60, 90 triangle. Yeah.
Where can I use this formula? The high by half basic equal area. Can I use this formula here?
Just do it again.
High
1/2 the base times I?
Yeah.
Okay,
high,
sure.
High by half basic
Sure.
equal.
The area?
Yes.
Sure. It's still a regular triangle. It still should have the same area formula as any other triangle. There's nothing special about it here.
Yeah.
Yeah. But, I mean, what this is really useful for is trigonometry. Right? This is not quite trigonometry yet. If we were talking about trigonometry, we'd be talking about sines and cosines and all that kind of stuff. But this is the very, very beginnings of trigonometry. And there is so stupid much you cannot do without trigonometry. It's absolutely silly how much stuff. You see people surveying out there, trying to make sure that the land isn't sinking too much or whatever. All of their job basically is built off of trigonometry. And so my little brother finally started understanding trigonometry is when he kind of followed a survey around and saw what the hell they were doing. Like, oh, Lisa, that's trigonometry. Yeah. Okay. And then one last thing to talk about before I leave chapter 12. And this is really, it's all basically based on this. And this seems coming out of nowhere, but if I have 2 points, and I want to know how far apart they are, right? I want to know the distance between those 2 points. So this is the distance formula we're trying to come up with. In my brain, I can already see the shape that we want to use here. But here's what we want, this distance between them. Now, normally, if I'm driving a car, especially around San Diego, where if you keep going in some direction, you might fall into a canyon. So you can't really go from here to there straight. But most of the time in any city, you got to go a few blocks over and a few blocks up. So this is as the crow flies, but what I could do in my car would be this. No, Jeff, not too far. And then this. Right? So I've got a nice triangle there. In fact, I know it's a right triangle because it's based off of x and y. Those have to be perpendicular to each other. So to find this distance here, it's really just based off of Pythagorean theorem. Right? So I just have to know how long this is and how long that is, and then plug it in. So how long is this? 6. What's the x part on this? 2. And what's the x part on that? How far apart are those two things? 6. Right? They're 6 apart. So it looks to be x1 minus x2. That sounds... Or x2 minus x1. I don't care which way. Let's do it that way. I think that's what you guys are used to. Remember from slope? This looks very much like a slope thing going on here, right? Well, we're more interested in the distance, not just the direction. And this, of course, would be how much? Yeah, this is 6 here. This would be 3 minus 1, 2. So then to figure out this distance, I just plug it in. Right? So I get d squared equals 2 squared plus 6 squared, and I can solve for the distance. So whenever it's at an angle from each other, it's not straight across from each other, that distance is going to be a little bit freaky. Because it involves an x piece and a y piece. Right? Yes, sir?
Could you do that 12.7 number 45? Could you do the setup for that? The one with the breed.
Oh, yeah.
I was trying to figure it out. I couldn't get
Let me finish this up. So, to get the distance formula in general, this is why I'm trying to put these down here too. The distance formula in general would be between any 2 points. If I have a point x1, y1, another point x2, y2. The distance between them would be the square root. Is that cool? Because you got to square root both sides. Square root of how far you went on the x-axis plus how far you went on the y-axis. So it's really just Pythagorean theorem, where A is this and B is this for that side. Cool. Most of you guys should have seen this distance formula already. I'm hoping a lot of you guys have taken geometry. So this is the distance formula built off of the Pythagorean theorem. And really, this section is really just all about applications of radicals. So they're talking about a few places where radicals show up. Oh, yeah. So, there's a problem in there about a bridge. Have you ever been near a lot of bridges? They normally have these connectors that have some space in between. And the reason that is because when things heat up, metal expands. If you don't put those spaces in there to allow for that room, the bridge is going to kind of press in itself, and if it's not strong enough, it's going to tear itself apart, basically, when it heats up. There's just not going to be anywhere for that to expand. It's a bad thing to have happen to your bridge. But this says this is 2 miles long to begin with, and then the heat makes it buckle. And they're saying, what if all of that happened right there? And it expands by 2 feet. So what if all that happened right in the middle of the bridge? It kind of like the only way it could go is up right in the middle. How high would that bulge be then? So the first thing you realize is I got miles and I got feet. The second thing to realize is I've got 2 little right triangles here. So I really just have to focus on one of them. So if this is normally 1 mile here, and it expands by 2 feet, how long is this going to be here now? How long will that be? So normally that half is a mile. The whole thing expanded by 2 feet. How long is that side now?
1 mile, 1 foot.
1 mile, 1 foot. Right? So first step is really converting that just to straight up feet. Right? I can't have miles and feet running around. I just want straight up feet. Anybody know how long a mile is in feet?
5,280.
I love it. So this will be 5,281 feet.
Oh, that's close.
Adding the 1 foot in. Cool. And how long is this here?
1 mile.
1 mile, 5,280 feet. So now you just got to figure out, well, how tall is that?
Okay.
Yeah.
That's easy. Right?
When you first read it, it's a little weird.
No, I couldn't figure out.
So I agree with you. Yeah. So for those with the white book, this number 45.
What section?
12.7. Yeah.
I couldn't get the height.
That's a good question.
I was thinking that was.
It's just 1 foot. Height is just 1 foot.
No, definitely not. Obviously not. Hopefully is the right thing. Because it's not linear. This is a different direction entirely, right? So they don't add and subtract like that. We know that. They have to follow, for example, the Pythagorean theorem just to figure them out. So it's not based on this minus that is this. Is this squared minus that squared? Is this squared? So it's not what you would think. So let's try it out. Now I'm curious.
That'd be
5,281 squared. Is everybody cool with that? I mean, what's the most important side in there again?
1 mile.
Yeah, the 5281, that's the hypotenuse. So it's that guy squared equals
Yeah.
h squared plus 5280 squared. So if I subtract that off, h squared equals whatever the hell that is. I don't know. 10,560. I think is it 10,560? Yeah? 10,560? That difference? What is it?
1.
With a 1 there? Oh yeah, I forgot the 1. Thank you. And then what's the square root of that?
$102.7.
102.7 feet. All right, now do you start to understand the weirdness of sides of triangles? I mean, these are only 1 foot apart in distance, but I mean, really think about this. If I this is how why triangles work this way. This kicks out. If I have a mile here and I go a mile and a foot, over the course of a mile, this has a lot of room to kind of grow. So my picture's not even near the right here, but over the course of a mile of running. So it all depends on how big of an angle this is to see how far away I get at the end. So that actually allows for a lot of room in there. That's kind of not obvious that would work that way. That's neat. I like that problem. So that's why you don't want to let that happen. That'd be kind of a large hump to drive over. Yeah.
So when you're like in the middle of the problem and you cross it out, are you subtracting it and then you take out the square and you're subtracting it?
Yeah, so 5281 squared minus 5280 squared.
Okay.
Right? Yeah.
And then you just subtract it like that and that's what you came up with.
Yeah, do this minus that, whatever those numbers are.
Okay.
And that's where the 10,000 comes in.
Okay.
Yeah. And just
Because I'm like doing them I'm taking in the parentheses and then squaring and in the parentheses squaring and it's getting really big.
oh yeah, don't do that. But I think I've already bored the hell out of most of you today, but I just want to show you. This is what I was doing in my head. This is how I got really close. I just forgot the 1. That is this. Is that cool? If I FOIL this, the first thing I get is this. So that cancels. So the answer is the rest. Plus 1 of these, plus, so I got 2 of these. So I did 2 of these, and then I just forgot to add in the plus 1 at the end. That's why it's 10,561. The power of FOIL. I had no idea that you could do that. That happens a lot. If you had to do 17 times 23, well, that's 20 minus 3, and that's 20 plus 3. It's a lot easier to do that. Some of the human calculators do something like that sometimes. Right. Anyway, so some of you guys, maybe about 3 of you, appreciate that. That's all right. Or the rest of you are just hiding your joy. All right. So that's not that. The real focus, that section is sort of a little side section, so do what you can with it. I want to desperately focus on chapter 13 today, which is really chapter 8 in the McKeague book. And the nice thing in chapter 13, we've sort of been talking about this stuff all along the way. Where they got that? There it is. Cool. I like it. Quadratic equations. Oh boy. So we've already done some quadratic equations. Here's an example of a quadratic equation. Yeah, you can factor. So you get x equals 4, negative 4. Now finally, if there's any of you guys who don't want to do that, maybe because you hate factoring to death, you can do what you maybe have wanted to do so far, which is just to add the 16 over. I'm going to let you do that now. All right, up till now, I need to see the factor. But now you can certainly do this. There's no other x besides the x squared. So the whole argument about not being able to put my x's together is kind of moot. I put all my x's together. There they are. There's my numbers on the other side, just like I'm supposed to do. But how do you finish this out? And now you understand why it's got to become second nature that you just immediately put down that plus or minus. That's the trade-off. Factoring, I see them. Square rooting, I've got to remember them both. Right? So I get x equals the plus or minus 4, just like I got there. That's the easy step. So here's the next level up from that. What if I had x squared equals negative 9?
Isn't that?
I think I heard made to the right answer. Careful up here. If you take the square root of both sides, put your plus or minus. What's the square root of negative 9? No. 3 times 3 is not negative 9. 3i. Right? You guys semi with me? So what's the square root of negative 25? Well, it's 5i. Right? I'm specifically saying, no, careful. So if I say what's the square root of negative 25, the answer is 5i. Because I'm specifically saying I want the positive one. I didn't ask for the negative root, right? What's the difference then with that and this question? Now I'm saying what squared is this? Well, there's two things squared is that. This one says I specifically want the positive root of this. So it's just 5i by itself. This one says when you square to get this, well, there's two answers. So we're going to square root, plus or minus 5i. Do you see the difference between those two situations? Here, I specifically said I just want the positive root. Here, I said I want to know everything squared to make this. And there's two things I squared to make that. Okay, of course, we are slowly working our way towards solving this equation. What's wrong with that equation with the methods we've talked about so far in this class? What would you try to do? Yeah, buddy. You try to factor this thing, right? And I can't. There's no factors of 1 that make negative 3. Not in my world, anyway. So we have to figure out some other way to do this. So that's the quadratic formula. Most of you guys should obviously know that. We're going to derive it. That's the way to spend your Monday after the 4th of July. So before we can derive the quadratic formula, we have to talk about something called complete the square. And people, for some reason, people really hate this. I desperately want you guys to see, no matter how ugly I make the numbers, the process, again, like always, math process doesn't care. Doesn't care if there's a 9 in there, or 3, or a square root of 2, it doesn't care. But I'm going to start off nice, obviously. So, the question really is this. Can I figure out a number to put here so that this will factor as x plus something squared? That's why it's called completing the square. What would I need to put here to make this factor like something squared? So that's the question we have to figure out. So let me give myself a couple examples then. What about x plus 4 squared? What do you get when you FOIL it out? Please don't say that. Please. You were joking. When you square something, you have to write it twice. So you get 4x, in the middle is 8x. There's your plus 16, right? So I can appreciate that joke. So then x minus 7 squared. What do you get when you do that?
14x plus
Plus 49.
Is that cool? You're going to get a -7, so -14 in the middle? Cool. If you have to write it twice, go ahead, but you really shouldn't have to. You should be able to figure out as you go. So what keeps happening? The middle number is always twice that. I like it. It added to it. So twice that dude. And the last number is always that thing squared. So this number, I can figure out what that number is directly just by taking this number and cutting it in half. So the first step in this process is cut the middle number in half. 10 divided by 2, 5. That number will always go right there into the factored form. You guys with me? No matter what the hell, even if it was 11. 11 over 2. Who cares, right? That's gross, but I don't care. And then the second step is to figure out what that number is. I take the number I just got and square it. So the next step is 5 squared. It's 25. That goes there. Maybe. That's the only thing I can put here to make it factor like something to itself, to make it factor like a square of something. That's why it's called completing the square. So if I put this down, what would you put here? And what would be there? The 2 steps.
4.
Yeah, first step, careful. -8 divided by 2 is -4, so that goes here. Second step, -4 squared, 16, that goes there. Right? So then a really good question right now is, how the hell does that help me? I almost said something else there. So how that helps me is this. If I had a question like this, if I had a problem like this, how would you solve it? I love it. Take the square root. Plus or minus. So those went away. So x minus 2 equals plus or minus 3. And I still love when the student came up and asked you where the plus or minus button was in the calculator. But that just tells you have 2 separate things to figure out, right? So x equals 2 plus or minus 3. So x equals 2 plus 3, or x equals 2 minus 3. 5 or -1. Sweet. So completing the square helps me when it doesn't start like this. That's why I want to be able to write it as something squared, because then I can take the square root of it. So now we have a process to do that. So let's try this one that way. So we're not quite to the quadratic, and to be completely honest, this poor little completing the square process comes up in a lot of different places in mathematics. This is one place where we immediately go for the shortcut. The shortcut to completing the square is quadratic formula, right? But we're going to do a couple with completing the square. I think first I'll do one that's a little bit nicer than this, and then we'll do that one. And then we'll talk about quadratic formula and do these again. See if we get the same answer. We better, or else I'm full of shit. Which I'm not. So I'm trying to solve this equation. I can't solve it directly because I can't factor that. Yeah.
Do you add to both sides?
I love it. So the first step is to make room, right? I need to have room here to put that result from what I get. So I want to add the 2 over that side. I love it. So get the 2 out of the way. Give me some room to work with. So what are my 2 steps to figure out how to complete the square here? Yeah, so first step. Divide 12 by 2 and I get 6. That's what goes into the factored form. Is that cool? Do you guys see what I'm doing? So I want to figure out what number do I put there so that I'm able to factor it as something squared. The minute I do that first step, it tells me the answer to the factoring. The 6 goes right there. And then what's the second step? Square the 6, you get 36. So some of you guys might be like, well, why the hell do I even care about the second step, Jeff? Because you got to have the right equation. I can't get here unless I put what there? 36. And if I put 36 there, I better freaking also put 36 on the other side. I can't add 36 to one side and not to the other side. That's the biggest mistake in this kind of problem, is to add one side but not the other. We suddenly have all this other stuff going on. We forget the most fundamental thing about solving equations. I added something here, I better add the same thing over there. So now this process has rewritten this problem like this. And now I can do like we just did a minute ago, right? Which is specifically what? What can I do next here? Square root it. Plus or minus. So we get x plus 6 equals plus or minus, and I can't do a damn thing with 38. It's 19 times 2. It doesn't have a part of it that I can do, so I just leave it alone. One last step and I'm done.
Add, subtract 6.
Subtract 6. It's just subtract 6, right? The 6 is just by itself. It's not plus or minus. So I get negative 6 plus or minus square root of 38. Yes?
How did you get the 12 from that 3?
Oh, so this is still not, I haven't done this problem yet.
Okay.
I'm going to do that problem in a minute because it involves some fractions. And I don't want the fractions to get in the way of understanding the process. Process doesn't care, but we care. So here, you guys try this one. Let me shut up for a minute. I've been talking way too much, which is some of you guys are thinking. Everybody else stuck it there? So of course the first step here is
Subtract 5.
get the 5 out of the way, make some room. And then the 2 steps,
Divide by 2.
and divide that middle thing by 2. Make sure that if it's negative, you bring that negative with it. So already I can write on the next level it's going to be x minus 4 squared. So what's missing is what's going to be over here. So the second step, 16, good. So to add 16 here, better add 16 there. Make it legal. So I have it equaling 11. I love it. Cool. Now,
Square root.
yeah, it's awesome.
Plus 9.
Square root, plus or minus. Square and square root go away. Add the 4. 4 plus or minus root 11. Cool. Just something you can kind of sink your teeth into. It's kind of nice. You get the process down, and the process just eats it up. Let's do that one together, and then we'll do the quadratic formula. Let me keep this somewhere. So finally, this problem's been sitting up there looking at us. First step, of course, is minus the 1. And now here's what the process saves our ass. Again, the process, I keep saying this, process doesn't care what's there. First step of the process. Yeah, so I get negative 3 over 2. Boom. So that's going to go where? In the factored form. I love it. So that's x minus 3 over 2. Right? Fractions, but they're going to go in, they just go in where they go in. There's not much to it. And then the second step here is
9 over 4.
good. Square this thing, 9/4, and that of course goes here and there. And what's negative 1 plus 9/4?
5 over 2.
Good, yeah. So it's 9/4 minus 4/4, 5/4. I like it. Let me stop there for a second. I'm getting fractions in my problem. I actually don't care. I don't know if you're with me yet or not. The process is the same. I cut it in half. If I can actually do it, I do it. If I can't, I don't. I just put whatever number that is there, square it, put whatever number that is there and there. Right? The process just kind of eats it up, no matter what number's in the middle. Now it's the same thing. What do I do? Square root, kill that. Plus or minus. Square root of 5. I don't know. Square root of 4. 2. There you go. See, you can simplify that. And then I just add the 3/2 over. Done. This one.
So wait, why is that 5/14 and you negative 1?
Yeah, negative 1 is negative 4/4, right?
Oh yeah.
LCD? Cool. Alright, so here's... Bless you. Yeah.
With the square root when a subtraction, I see this is the second time you do it. You just go straight like the 5 you can't square, you just leave it alone, and then the 4 you take the square root.
Oh yeah, yeah. Because, what's the square root of 9/4? 3/2. Because it's square root of 9 over square root of 4, which is 3/2. Square root of 5/4, square root of 5 over square root of 4, which is 2, and the top I can't do anything with it. Or nothing that I want to do, anyway. Right? There's no nice way to write that. Except the way it is. Yeah. Cool. So here's what's always painful for students, but if you want to look away, I understand. But it's in the book also, page 810. But the quadratic formula takes an equation like this, works with that exactly as it is, and figures out an expression for x based on a, b, and c. Now, a, b, and c are going to be numbers normally for us, right? In this case, a, b, and c was 1, -3, and 1. So if you've worked with quadratic formula before, you understand that point about picking out what a, b, and c are is kind of important, so you can plug it in the right place. I don't know if you've all seen this before or not. I'm going to go through it a little bit quick. We'll see how that goes. But the first step really is, and we haven't really gotten into this with those kind of problems, but every single one we've done so far has had a 1 first. And you actually need that. So the first thing is to divide by a. Don't write this down, but it's all in the book. On page 810 in the white book. Probably somewhere in section 8.2 in the blue book. If they did this, I don't know. Now, what's the first step, really? The first step there was just divide the a out of the way. Now I've got something that looks sort of like that, believe it or not. Yeah, get that thing out of the way, right? Make some room. Now here's the process comes in. The process doesn't care. There's some ugly stuff going on here, and the process, I don't care. What the first step is, take this, cut it in half. Dividing by 2 is the same as multiplying by 1/2, so I just get b over 2a. That's that thing cut in half. So really, take b over a, cut it in half, I get b over 2a. So where's that going to go? It's going to go in here. So I'm going to x plus b over 2a. Now everybody sort of loses it a little bit when things get to the point. This is where you really, if you're able to focus on the difference between process and actual elements in there, I know the process. That's why I would feel comfortable you putting whatever the hell you want to there, and I could just kill it. Because I know the process. I don't care about b over 2a. That's ugly. I don't care. That's just what came out of my process. Who cares? What goes here? How do I figure that out? Yeah, take that number and square it. B squared over 4a squared. So I have to add b squared over 4a squared. I don't know if you remember this, but we had an example last week where we had to do this addition. Get the like denominators. So what would the LCD be here? Yeah, so this guy's missing a 4 and an a. Good. So I'll get, let's see where I'm writing. I'll get b squared over 4a squared minus 4ac over 4a squared. Is that cool? So I get x plus b over 2a squared. B squared minus 4ac over 4a squared. Good Lord. So then, what's the next step? Square root. So I get x plus b over 2a. The square dies with the square root there. Equals plus or minus. What's the square root of 4a squared? 2a. I love it. And where am I at? Oh, square root of all this crap, I have no idea. Please, dear God, square root of b squared is b, I know, but that has nothing to do with this problem. I don't see a b in there. I see a b squared minus 4ac. I can't take the square root of that. I leave it. Right? And the last step is subtract that over. And does this sound familiar? Negative b plus or minus square root of b. Yeah. course, if you don't already know it, you have to know it. Yes?
You had to do all
Yes.
That's just to get
You had to do all that to get to the quadratic.
Exactly. I don't understand teachers that just say, this is what we're going to use. And if you ever have a teacher like that, you should say, where the hell did I come from? I know the other students will probably hate you. But you have to be like that. Where the hell did that come from? It's good to know where it came from. Even if you don't quite understand some of the steps I took, you can all see the process. Right, move that thing out of the way, cut that dude in half, square it. You can kind of see where things came from. Even if I lost you somewhere here, it's still just working the process. So this is completely valid. Uses the idea of completed square, which is completely valid. So now what I've done is, this is the power of being able to work with multiple variables. Now A, B, and C can be whatever the hell you want them to be. And you've got an expression for the answer. Shit straight, right? Whoa, I didn't know I could hit that. So let's double check that one, the only one I have left up on the board. The one there, 12x and the 2. Let's see if we get that same answer. Of course we will. So in that problem there, x squared plus 12x minus 2, what's A? A is 1, B is 12, C is negative 2. So x equals negative b, give or take, b squared minus 4 times a times c, all over twice a. Yes, ma'am.
Well, let's say if the b were to be negative, would it have been the opposite? Would it be,
Always the opposite of what it is, sure.
so then,
It was positive, now it's negative. If it would have been a minus there, this would have been a plus 12. Yeah. Does that look at all like that? It's supposed to be this answer. Well, not totally yet, but I can see the negative 12 over 2 is negative 6. That looks promising. What do we get in the inside here? 144 plus 8. So 152. Can you simplify that radical? Why did I say it like that?
this is Monday.
It must be. Yes, 4 will go in. 4 is a good number to go in because then I can take the square root of it. 38. Cool. So it's going to be negative 12 plus or minus square root of 4 times 38. Yeah, it's over there. That's why I was smiling there. So that's negative 12 plus or minus square root of 4 is 2. And here's the biggest mistake I see. People will like kill those 2's and leave the 12, and that's crazy. Nobody can escape. Nobody expects the Spanish teachers. So I can only do this division if I divide everything by 2. So negative 12 divided by 2 is negative 6. The 2's cancel here. Bam. Right? Yes, ma'am.
so let's say if would it be 4 squared, you would just put the 4 in, right? Or would it have to be 1?
Where are we at?
Let's say if that were to be 4 squared plus 12x and everything, you would just put the 4, it doesn't matter.
Oh, no. A, B, and C are the coefficients. If I had 4 squared plus 12x minus 2, is that what you're saying?
4x squared.
Oh, okay, 4x squared. Gotcha. Then A would be 4, exactly.
Yeah.
Good. I'm with you. Okay. So, quadratic formula, I can't make it any easier. Once you get through the derivation, which you have gotten through, you'll survive that. I don't have t-shirts for you, but you'll survive that. Once you get through it, you just have to memorize the thing. And then it's beautiful. It's just plug and chug, plug and chug, plug and chug. You will get some answers that are complex, right? And I don't know if you've ever been shown this or thought about this, but what does this kind of thing look like graphically? What would it look like if I graphed it? Next squared kind of thing. What's it going to look like? A U. U shape, right? Any x squared is going to have a U shape to it. So, I mean, in this case, it's got 2 roots. It's going to go through the x-axis twice. It's got 2 real roots. If I have a problem where it doesn't have any real answers, they're both complex, that means the parabola was like that. It doesn't have any real intercepts. They're complex intercepts. So what kind of problem would that be? That'd be a problem like, like what? I don't know. I just have to make sure about what really would make this complex? What would make the solution to this complex? How did I create that equation knowing it's going to be something with I in it? What part of this would bring me complex answers? What is a complex number? Square root of a negative number. So what's the only part in here? The square root. So if b squared minus 4ac is negative, I'm going to get complex answers. That means my parabola is never going to hit the x-axis. That's kind of neat, right? So how did I know that? Well, what's b? Negative 2. What's a and c? What's a? 1. C is 5. So what's b squared minus 4ac? 4 minus 4 times 1 times 5. So 4 minus 20. I know it's going to have complex answers. Because my b squared minus 4ac is negative. The part that's under the radical. So, finish that out. I've done a lot of the work for you, right? Just finish that quadratic formula step out. Remembering that your answer should be complex. Oh yeah, here we go. We already did the b squared minus 4ac work there. So just plug that into the square root. What is the square root of negative 16?
4i.
Good, 4i. And of course 2 goes into both of those. So I just get 1 plus or minus 2i. So you get my 2 answers that I'm guaranteed by the fact that it's a squared, the second power in there. All right, cool. So you can kind of know ahead of time, if you just look at the b squared minus 4ac, if you just look at that piece, you know ahead of time if it's going to have real answers or complex answers. How to make it have one answer? And what the hell would that mean? How could this possibly have one number answer?
Just x not x squared. Just x not x squared.
Well, that's one way. It's not the only way. Do the same thing I just did here. To have imaginary answers, that's got to be less than 0. To have real answers, that has to be greater than 0. What's the part of this equation that gives me 2 answers? What really is it that gives me 2 answers? Sort of. The plus or minus. So if this piece here was 0, I would get 1 answer. So if I have a situation where b squared minus 4ac equals 0, I'll get 1 answer. So if I had a problem like this, What are you doing yourself? There. Too much. So a problem like that, I'm not going to use factor, but what would the b squared minus 4ac be? What's a, b, c?
1 minus 1.
So what's b squared minus 4ac? That would be 16 minus 4 times 1 times 4. 16 minus 16, 0. But I can factor the dumb thing anyway, right? How do I factor this? X minus 2, x minus 2. So then I get x equals 2. Right? And Jeff said you're supposed to get 2 answers if there's a squared, and you do. You get 2 twice. So you still get 2 answers. They just happen to be the same. It's just repeated. Right? But that's one situation. What would that look like graphically? No answers, the parabola never hits the axis. 2 answers, it hits it twice. 1 answer, it's got to hit it once. Its butt has got to be on the axis, right? Just to be very technical. It's got to hit that thing once. It's got to come in, hit it, and go away. That would be the graphical representation of that. Okay, maybe. So, we got plenty of time to kick ass. Let me give you one more. Here, solve this problem here. Okay, good.
Divide by 3.
No. No need to. If I just say solve this, I am not going to use completing the square. Hell no. Right? You know I'm going to say solve using completing the square. You know I'm going to say that. But if I don't, quadratic formula is a shortcut to that. So I would so definitely use quadratic. I can't use it right now because I don't know what all the coefficients are because it's not in the right format. Right? What do you do after this step here? Just to make sure everybody's on the right track.
Equals 0.
Get it equal to 0 because you got a power other than 1 on one of your x's, right? So add the 7 over, subtract the 5x over, and now I can either factor it or quadratic formula it.
Why did you change the order? It was 6x plus 4x, and then it turned like.
Yeah, it desperately has to be that way, right? I mean, it doesn't have to be that way, but it sure as all hell helps me save myself from myself. It's got to have the a's got to be in front of the x squared, the b's got to be in front of the x, and then the c's got to be the number by itself. But I always get, if somebody writes this down like this, they tell me a is 4, b is -7, c is, that's not true. B is 2, right? So I always just put it in descending order, the same as the form that we're using, and that'll keep it straight. But A, B, and C are.
I have a question for the 5x minus 7.
Yeah.
Did you just change the sign for the 5x, or did you also?
Oh yeah, add the 7.
Oh, okay.
And subtract the 5x, yeah.
from there we use the quadratic formula.
Oh yeah. Yeah, now you know what A and B and C are. Good. So that said, what is A, B, and C?
Three.
3 minus 1.
I love it. Now you just plug it in. So x equals,
1.
good, negative b, so negative 1 plus positive 1, plus or minus?
Minus it.
1 minus
Good, square, b squared 1 minus 4 times 3 times 1, right, AC, all over
6.
twice 3, 6. So we're going to get real or complex answers here. Complex, I love it. So x equals 1 plus or minus 1 minus 12. What's up?
You multiply 3 times 1, and then you multiply that to 4.
Yeah.
Then how is that? 2 goes on the bottom. 2 times alpha.
So yeah, this is 2 times a. This is not the answer there. This is one big thing. X equals that thing. Negative b plus or minus blah 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 over 2a twice 3. Yeah. So 1 minus 12 is definitely negative 11. And the only thing that you really do there that you really have to do, I can't simplify radical 11. But what do I have to show up explicitly here?